Welcome to the presentation on climate change in the Baltic Sea. My name is Gerald Schernewski. I'm head of the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research in Warnemünde, Germany. At the same time, I'm professor at Klaipeda University in Lithuania. What are we going to talk about? You will get an overview about climate change aspects. We start with sea level rise, focus then on increasing temperatures and the consequences, carbon dioxide increase and pH, acidity, salinity, stratification, oxygen, and we finish with precipitation and the consequences on riverine nutrient loads. And at the end, a brief general conclusion. Sea level rise. During the last century, we observed globally a sea level rise of about 1 to 2 millimeters per year. This increased to 3 to 4 millimeters per year during the last decades. And for the future, until 2100, this might increase further to 10 millimeters per year. So sea level rise is an important issue. But for the coasts, more important is the intensity of storms. This figure shows storm surges observed in Warnemünde at the southern Baltic Sea. In the 50s and 60s, there were 2 storm surges. Heavy storm surges. This means surges with a water level above 1.5 meters. But recently, we observed storm surges more often. So there is a tendency towards a higher likelihood of storm surges. What we cannot say, based on our model results, is whether extreme winds and extreme waves will become more often in the Baltic Sea. Already during the last century, we had a serious problem with coastal erosion, mainly as a result of storm surges. And this picture shows northern Germany, at the Baltic Sea, the federal state of Mecklenburg-Vorpommern. And the red dots indicate a coastal retreat, coastal erosion. And you immediately see nearly everything is red. There are some green spots where accumulation of sediments take place. In one area, close to Rostock, we even had a coastal retreat of 210 meters during the last century. Already today, we face annual costs of about 15 million euros for coastal protection. And of course, when erosion increases in future, these costs will increase. Another important aspect of climate change is temperature, the rise of air temperature. Globally, we observed during the last century an increase, and this increase was even stronger in the Baltic Sea region. And for the future, depending on the CO2 emission scenario, we expect a further increase of 1.4 to 3.9 degrees Celsius. And extreme summers will become more likely. Water temperature behaves similar. Here as well, we saw an increase in temperatures of global oceans and an even stronger increase in the Baltic Sea region. And in future, the increase will be between 1.1 and 3.2 degrees until the end of the century. This means water temperature behaves very similar to air temperature. What are the consequences of temperature increase? We will get a stronger utilization of our beaches, increasing bathing tourism, because we will get a longer season. And what we observe in Germany is an increased urbanization pressure. So people from southern Germany, where it becomes in summer too hot, move to the cooler coasts. At the same time, we face erosion and we occupy space because of coastal protection measures. This means we will get a coastal squeeze, more people on less space. This has consequences. Increasing costs of beach maintenance, increasing pressures on coastal habitats, so it will be very hard to avoid tourism on natural habitats, to protect them properly. We get a modification of the coastline, a lot of hard substrate measures, as shown in the picture on the right. And we get a competition between uses. For example, with respect to offshore sandbanks. They serve as natural habitats, are protected, but the sand is needed for beach nourishment to replace eroded beaches. Another example, temperature and fish. In general, one can say that it depends very much on the region in the Baltic Sea and the fish species, how climate change will cause effects. In general, one can say autumn spawning fish may suffer, but spring spawning fish may benefit from climate change, from higher temperature. But what we see with respect to a few species is that there is a problem that they miss optimal temperature windows. And this may lead to a reduced recruitment and lower stocks. Example is cod and especially herring. Consequence for fisheries is that the trawling season in the north will be expanded, but that in general fishing takes place more in the southern part of the Baltic Sea. And, of course, recreational fisheries will benefit from the situation. But let's come to the example of herring. The figure on the right shows the recruitment of herring, of young fishes, between the early 90s and 2020. And until about 2005, we had a high recruitment indicated by the blue line. And then suddenly everything dropped. So the number of spring spawning herring larvae decreased suddenly. And therefore the herring catches dropped from about 200,000 tons to only 10%, 22,000 tons. So what is the reason for this dramatic change? So the higher temperatures cause a higher spawning of herring in spring. The eggs develop faster and the larvae hatch earlier. But the problem is the larvae need food. And this is zooplankton. So they need the food 3 weeks approximately earlier today than 20, 30 years ago. But this zooplankton at that time is not available, because zooplankton is driven by the availability of phytoplankton, of algae. And algae depend on the light conditions. So the larvae starve. This is an example of the decoupling of a food web. And this has strong ecological and economic consequences for fisheries, of course. Another example, increasing temperatures and bathing water quality. In recent decades, we became aware of the risk of Vibrio vulnificus bacteria. They are natural, but several people died after an infection, after going for a swim. We now have a monitoring, and we can inform people, but we face the situation that Vibrio vulnificus develops very fast at temperatures above 20 degrees. And these temperatures in summer are common, especially in the shallow lagoons, in shallow bays. And we have a long season with temperatures above 20 degrees. And this is not only true for Vibrio vulnificus. Here an overview about human pathogens in bathing waters. And on the right-hand side, you see yellow and green, the pluses. The pluses indicate these organisms benefit from climate change. And we immediately see many human pathogens benefit from climate change. And this change may even allow new species to enter the Baltic Sea. So we may get new pathogens, but we will not detect them with our existing monitoring. So we face an unknown risk. Of course, temperature has consequences on sea ice. And the maximum ice cover during the last decade has decreased by 6,700 square kilometers. And in total, it has already decreased by 30%. And this decrease will become more intensive. So we will have a decrease per decade of 11,000 square kilometers. This means at the end of the century, winterly ice cover will be restricted to the northernmost part of Scandinavia, and our southern Baltic coast will usually be ice-free. As usual, this has benefits or causes benefits and problems. Mussel farming may benefit from this situation. Mussel farming is not common in the Baltic Sea, but we can use it to remove nutrients, to reduce algae blooms, to increase water temperature. And they are a high-quality source of proteins. And mussel meal can substitute fish meal. High temperatures expand the growing season in general, increase the yield, and, even more important, at the moment, these installations are threatened by drifting ice, and in future, they will not face this risk anymore. So mussel farming clearly might benefit. A different topic: carbon dioxide and pH. Increasing CO2 concentrations mean a decreasing pH in the sea. This is called ocean acidification. And this already takes place. In the Baltic, this can potentially be compensated by alkalinity entering with the rivers, by components that buffer this process. But as soon as we double the CO2 concentration, there will be a decrease of pH in the Baltic Sea as well. Again, some benefit, some suffer. And here it is the mussel. Mussels need calcium carbonate for their shells. This is more difficult to get this carbonate under lower pH. On the other hand, jellyfish may benefit from this situation. And jellyfish is an issue. So high temperatures extend the growing season. They can stand low pH. But another aspect that affects jellyfish amounts and mass developments is overfishing. So if they don't have competitors, such as fish, they can grow. And this has several consequences. So jellyfish preys on fish eggs and larvae, so reduces stocks. But they prey on zooplankton as well, so they reduce the food available for fish. So they have strong effects on fish stocks. And new species may enter our systems. The latest one is the sea walnut on the top right. And mass developments can become problems for fisheries and tourism. Fisheries by blocking nets. Tourism because people don't want to go for a swim if they face such a situation. Even if the species, the moon jellyfish, Aurelia here in the Baltic Sea, is not dangerous at all. Another topic is salinity and stratification that is affected by climate change. So during the last decades, the stratification increased. Stratification means the water body of the Baltic Sea is layered. A top layer, a bottom layer, and in between a layer with strong gradients. Gradients in temperature and salinity, saltiness. So this gradient soon separates lighter water from heavier water. And the important aspect of this stratification is that it hampers vertical exchange. Due to warming, it is suggested that the vertical summer stratification will become stronger. How climate change affects salinity stratification is uncertain. So we may get more fresh waters from the rivers, but sea level rise may increase the amount of North Sea water, saline North Sea water, that can enter the Baltic Sea. But this salinity, or this stratification in general, is a serious problem because it has consequences for the oxygen concentrations, especially at the bottom of the Baltic Sea. And recently we observed about 70,000 square kilometers where at the bottom of the Baltic Sea oxygen was depleted, the so-called dead zones. Climate change may enhance this oxygen depletion, but climate change is one aspect. Our nutrient management, the management of nitrogen and phosphorus, the management of eutrophication is in this respect more important. This gives you an impression of the oxygen-free zones in the Baltic Sea. In black, the permanent zones. So it's really a large area that is covered. And the changes in deep water oxygen concentrations are of very high importance for the entire Baltic Sea ecosystem. But again, it's climate change on one side, but nutrient loads on the other hand that are important for the size of hypoxic areas. Before we come to the nutrient loads, we have a look at precipitation. So average precipitation amounts are expected to increase, especially in winter in the north, but partly even in summer, while the changes in other regions in the southern part are uncertain. But the models suggest an increase in the frequency and volume of heavy precipitation. And rain ends up partly as river runoff. So, as a consequence of stronger rain, and especially in the north, we will get more runoff, 2 to 22%. So more fresh water is entering the sea. This is especially true for the north again and uncertain for the south. Floods are projected to decrease in the north because usually they were related to snow melt. But they may increase in the south. What does it mean for the nutrient loads? Because the river transport nutrients. And here we clearly see that the management of the river basins, the nutrient management, has a much greater effect on the loads and on eutrophication of the Baltic Sea compared to climate change. For example, if we carry out model simulations and we have a look how nutrient loads affect chlorophyll concentrations in the sea, this means phytoplankton, algae biomass. We see this yellow arrow, and there is a slight increase if we assume climate change alone. But as soon as we meet our international load reduction targets, the Baltic Sea Action Plan, there is a strong drop of concentrations. This means how we manage our river basin determines what happens in the Baltic Sea. So, some conclusions. Climate change affects the Baltic Sea ecosystem in multiple ways and may cause some strong, especially local, effects. But usually, human pressures, nutrient loads, fishing, have a much stronger effect on the ecosystem compared to climate change. And especially in the southern Baltic Sea, sea level rise and coastal erosion seems to be the biggest challenge for the future. But as always, climate change has benefits as well. Increasing temperatures very likely will increase, especially tourism. So we face a future with many uncertainties. And with this, I'd like to thank you for your attention.